Okay, so the second formula I want you to think about is the electric field, which is often denoted by vector notations. So it's Fe over Q or volts per meter, right? Now, we know that you could use this here, and we also know that Q is always equals to IT, or it could also be CV. But for simplicity purposes, we'll use I here, so that'll be V over D, right? And so we've done that, and we know that I, according to Druid's electron motion theory, is number of electrons times the cross-sectional area times the velocity of each electron times the charge each electron carries. So if we're doing the Millikan's oil drop experiment, right, where we're shooting an oil droplet, and we want it to get stabilized right in the middle, and we balance the electric field in such a manner that it gets stabilized in the middle or somewhere between the two plates due to V over D, right? So what we do is we input this here. Now this Q is not the same as this one, because this is quantized charge, and that's the actual whole charge running through the circuit. This is one aspect of the charge, whereas this is the cumulative aspect of the charge. So what you need to realize is that this is one charge or one electron, whereas this is the cumulative charge circulating through the wires of the circuit, which may hold a capacitor, a resistor, an ampere, a voltmeter, a switch, a battery, and whatnot. So now if we substitute, bring it here down, we get rho Vg n V q times T equals V over D, right? So we got that, and so this is volume and this is velocity. So this needs to be clarified. Rho times V, and then we've got voltage here, and now we know that volume decomposes into area times length. So what we can do now is we could cancel out the area and just leave length here. So it'll be, cancel out the area, A's cancel out, so it'll be rho L G over N V Q T. We know that L over T is velocity, so this velocity will get cancelled out by this velocity, so we cancel that out. We are now left with V over D equals, from here, rho times G over N times Q. Rho over G N times Q. So now we need to find out whether this equation is homogeneous, whether it comes out to be either in newtons per coulomb or volts per meter. So if we do kg per meter cubed times newton per kg, we could cancel out the kgs, so we get, and then we've got coulomb down here, and then we've got a number. So all in all, it is sort of it should be completely dimensionally homogeneous, but here it's newtons per meter cubed coulomb. Given my understanding, it is correct, because we are talking about the electric field of a particle experiencing a 3D electric field. So the volume has come needs to come into consideration, whereas E equals F over Q is just like is a very simplistic version of electric field expressivity. So in order to get a full picture, we have to have some form of volumetric quantification in the numericalization of electric field. Although this isn't there, but in this case it is, and it's not that wrong. Thank you very much. I hope you enjoyed it.